So first, IPFS is or Interplanetary File System. So why would you need something like this? Uh, let's say I actually ask you to find a book. Rather than giving you the name of the book, I give you, the latitude and longitude at which the book is there. And I also like to tell you the shelf number in which the book is there in the library. But if you go there and you figure out that the book has been placed somewhere else, or you can't find if the library doesn't have the book, you won't be able to find the book. But normally that's not how we actually do things. So we usually find things by name. Like if I want to get a book, I would actually like tell you the name of the book or the ISBN number, which you will actually use it to first check if you already have the book, or if you don't, you will check your local library, or you will check it like in a like in somewhere else where you can actually find the book. But weirdly enough, that's not how computers work. Especially the way you actually do it is like when you, let's say, visit google.com, it actually hits like a domain name server, and that actually gives like an IP address. And then your computer actually makes a request for a file in that IP address, and then it actually gets the file. So this is called as location-based addressing. And so why is this actually a problem? Let's say you wake up tomorrow and your Gmail, your Notion, and like all the data that you have on the internet, like all the centralized servers are actually gone. What would you do? Uh, and like imagine like all the critical systems that run the world. Like internet is like a nervous system. So that we have built collectively. If it stops working, then it's a big problem, right? And also with this location-based addressing, you have the centralized server. So these centralized servers are much more prone to attack by bad agents, and also it can be down due to technical reasons, and like you won't be able to access it. So how do we actually solve this? So IPFS actually comes with a solution called as content-based addressing. So you tell the network what you actually want, rather than where to find the file. Then it'll actually try to figure out how to get that particular resource, and it'll give it to you. And if the resource is present with, like if you already have the resource, it'll like give the resource to you. Or if the resource is present in the network, in some like node closer to you, will actually fetch it from there rather than reaching to the computer on the other side of the planet. So how does this IPFS actually do it? Let's say you have this cat image, and so this cat image is actually passed through a hash algorithm, and this hash algorithm actually converts this cat image to a unique fingerprint, like a unique set of strings. It's like a fingerprint of this cat image. So you can be sure if something in the cat image has actually changed, this strings will actually change. So when like you are, rather than requesting for the file name, which might not be unique, you can actually request for this particular strings, and the IPFS network will actually be able to figure out like how to actually fetch uh, this particular file. So how does IPFS actually store the data? So IPFS has this object-like structure. I mean, IPFS object has this structure where it has this data object, which actually stores the actual, the content of the file, and it has this links, which stores links to other IPFS objects. So the catch here is this data object actually can be only 256 KB in size at max. So when you have like a very large image, like this cat image, which probably might be 3 MB or 4 MB, what IPFS does is basically breaks this cat image into multiple smaller IPFS objects, which are linked together. And when you request for this, when you have like another cat image, let's say you have that has this same cat image with the shades on it, and IPFS will actually only download the parts of the file that you already don't have. That way, your file download is way faster than like your traditional file. I mean, traditional network. For example, if you were downloading this file again in your traditional network, and like it'll download this, and when you request for another file with the same image with a cat with shades on it, it will like download the whole 3 MB file size again. But in case of IPFS, since it's actually fragmented like this, it'll actually download only the diff. So this is actually like a lot of concepts here are actually borrowed from Git. Git actually works a similar way. So IPFS actually catches up something from that. And there's no like a central server in IPFS, and all the data in IPFS is actually stored in peers. So that way, when like some parts of the peer actually are offline, you will still have other peers who still have the file. And because of this hashing, the file is actually deduplicated between all these like nodes in the network. And yeah, it's 256. So what can IPFS do beyond web pages? There is an actual, there's a database called OrbitDB, which basically is like a database built on top of IPFS. And there are like a lot of cool applications. There's one called AnyType, which is basically like Notion, but built on top of IPFS. That way, your data is actually not stored in like a single server. And whenever, you have like other a node in your private IPFS network, which actually connects to your node, it will get request for those files, and it will obtain the copy of those files. So yeah, let's actually show a demo. So I think I should start sharing. So yeah, this is IPFS. IPFS has like a couple of tools. This is IPFS desktop, which is like a GUI for IPFS node, and they also have like a CLI, which you can use. So what you can actually do is, let's say you have these three cat images. If you actually look at it, these cat 0 and cat 1 are actually the same image, just with a different file name. And cat 2 is like the same image, but with the cat's shades on it. If I upload these three files to IPFS, if you actually look at it, cat 0 and cat 1 actually share the same strings, since they both refers to the same file, like a content, but they just have like a different file name. So whenever you have downloaded cat 0 and you're requesting cat 1 in the network, in an IPFS network, it'll actually download. It won't actually download. It'll just like tell you that you already have this file, and it'll just show you the file. But in case of traditional network, this would have actually been like re-downloaded. So the way you can actually access, let me share my desktop. So there are a couple of ways to access IPFS. So in case of Brave, the Brave browser, it actually supports IPFS by default. If you have like another browser, you can actually install like a supporter extension. In case of IPFS, Home Store, you can actually install IPFS Companion. This will actually allow me to access this IPFS URL. I'm not sharing it. I don't think I'm sharing it. Yeah. So here, what I can actually do is like I can actually copy this link. If you actually look at it, it starts at IPFS colon colon, and like you can actually visit it. It'll actually show the cat image. This is an actual like IPFS file. I just like upload it. If you visit the same link, it'll actually download this file, and when you visit the other link, it'll actually download the other file. So what is like, why is it actually called as a IPFS or interplanetary file system? So because of the way it is actually structured, IPFS can actually work at like a very long distance. Like it is actually truly interplanetary in the sense like if you have like a traditional, let's say if you're accessing Notion and you're in Mars, and it would probably take a 4 minute um, round trip for like the request to come here and then like go back, probably just guessing. And that is actually like a very long latency. But if you were using something like any type, for example, if which is like a Notion, but but built on top of IPFS, the way to actually work it'll first check the local peers near you if they have the file. If they don't, then what it'll actually like request for another peer like on Earth to get the file. That way, it's truly interplanetary. And the way IPFS is, because of the way the IPFS is structured, it can actually support much more than just web pages and databases. And yeah, I guess that's it.